All right, so we're off into homework set 18, homework set 18, and I'm just going to do two problems. The first one here is problem 31 on page 255. Sister problem that you have assigned is 30 on the same page. And this is about composing functions and finding their domain. So it's a fairly straightforward topic. Let me run through these things. I'll probably need to kind of work through a problem and erase it and write down the answer and then move on. In fact, this is going to be a little difficult to get this on one screen as I look at it. So let's go. Here comes, there's f of x, x over x minus 1. There's g of x equals minus 4 divided by x. What is f of g of x is the first problem. And in order to do that, when you compose f with g, what you do is replace the argument of f with the function g. So f of g of x is the same thing as f of g of x. And that means every place I see an x, I'm going to put a g. So here's what f of x looks like. I'm just going to write it like this for a second. It looks like, put the argument there, subtract 1, yeah? And the argument's x, x goes there, 1 goes there. So what I'm going to do is put in g, all right? So g goes here, g goes here. What is g? Yeah, good question. F of g of x is then g minus 4 over x all over minus 4 over x minus 1. It's got compound fraction here, so let me fix this by just multiplying top and bottom, every term on the top, every term on the bottom by x. 4 over x times x is minus 4. Minus 4 over x times x is minus 4. Let me do that again. Minus x. Let me multiply everybody by minus 1, and I'm going to get 4 all over x minus 4. And there's your answer in lowest terms, in fact. 4 all over x minus 4. Okay, and as promised, let me make some space here and do that again. Let's this time do g of f of x. A little shorter now, g of x. The way the g of x works is you take the argument, put it underneath 4. So let's let the argument of g of x be the function f of x, and then g of f of x is minus 4 on the top, f on the bottom, x all over x minus 1. And when I multiply the top and bottom of this fraction by 1, written x minus 1 divided by x minus 1, then I'm going to get minus 4, x minus 1 all over x, and let's write that as 4, 1 minus x all over x. I'm going to take that sign and flip the x minus 1 to 1 minus x. And I'm going to move on and try to do this one, these next two pretty quickly. F can be composed with itself when it is. Every place you see x, you replace that x with f of x. So I see an x, I'm going to replace that x with an x minus 1. Great, that takes care of that. Now let me do it down the bottom. Down the bottom, every place I see an x, I'm going to replace it with an f. And there's the 1. So to clean this up, again, I'm going to multiply everybody by x minus 1. I'm going to get x on the top. I'm going to get x minus 1 on the bottom. And so to write the answer down here, what the heck is that? That is x all over x minus 1 is x. Okay. Hopefully you can see through that. A little bit of algebra. And let's go on to find g of x. Every place I see an x in g, I'm going to put a g inside of it. So this is equal to minus 4. Instead of writing down x, I'm going to write down g of x, minus 4 over x. Yep, so to fix that, multiply top and bottom by x. minus 4x all over minus 4, that's equal to x as well too, which is kind of odd. I'm not going to allow myself to think about that. I'm just going to move on. And moving on is the last part here. The last part says find the domain of each one of these functions. Now, finding domains of composite functions is a little bit trickier than just finding domains because there are two functions involved, not just one. There's g of x, there's g, which has a domain and it has a range. Yeah. But there's also the blue function, f, I wrote that wrong, which has a domain and it has a range. Range of f. And what I'm interested in is finding, in this case, the domain of, what is the domain of f of g of x? And you can see it's a little bit tricky because, there is only some fraction of the range of g that overlaps with the domain of f. I should have said that it may be the case that there is only a fraction of this entire range of g which overlaps and can be put into the domain of f. It can be put into the function f, right? And therefore it's only this little fraction, I wish I had written that in a different color, that maps into a fraction of the that maps into a corresponding fraction of the domain, the range of f. And ultimately what it says is there's a little area of the domain of g which maps into this. This is the domain of f of g. This is the range of f of g. So like I said, a little bit more complicated than just finding the domain and range of a given function. Let's see what that means up here. So if we want to find the domain, such a nice picture, and I'm going to just eliminate it right here. Your book has that same picture. If I can do two things at once here on page 294. You can stare at that and see if you can understand it. But in fact, what we're going to do here is to say, look, the domain of f of g, here is f of g of x. And it certainly looks like that the domain of f of g of x is just all x except, how do I write this? It is x does not equal to 4, right? Because you can put any real number into this domain, into this function, except for 4, and you can, any other real number returns a number, also a real number, and so the domain is all reals except for x equals 4. I wish you were done there. I wish you were done, because if we look back at g, remember g has to be inserted into f, and if you look at g, the domain of g is x cannot be equal to 0. So it's not possible for you to put x equals 0 into this function, even though it looks like it's perfectly fine when you look at the overall composite function. It looks like it's perfectly fine, but if you go back up here, g is not defined at x equals 0, all right? And therefore you can't put the value 0 into g and therefore into f, since g is not defined. So the domain here is f, x does not and x does not equal to 0. And we're going to do the same thing here. Here's g of f of x. This overall function would tell you that it's got a domain that x cannot be equal to 0. But let's go back up to the top. Look, x cannot be 1 in the case for the function f of x at x equals 1. F of x is not defined, and therefore you can't put it into g. So in this case, the domain of g of f of x is x can't be equal to 0 and x cannot be equal to 1. Back up top here, this would appear to mean that the domain of f of x is all reals, because you can put all real values into to x here. But let's look at f. The domain of f does not contain the value x equals 1, and therefore you cannot put f of x equals 1 into f. So the domain of f of x is x cannot equal 1. And in the same manner, d of g is x cannot equal 0. So there you have it. There's the answer to problem 31. We're out.